All right, welcome to the second lesson of the Ratios and Proportions unit, and today we're going to be talking about proportional relationships. By the end of this lesson, I am hoping you'll be able to determine whether a relationship is proportional or not. So, example 1, pay by the ounce frozen yogurt. So this is very similar to like orange leaf, where you have to put everything in a container and then weigh it. So pay by the ounce frozen yogurt. So new self-service frozen yogurt store opened this summer that sells its yogurt at a price based on total weight and its toppings in a dish. Each member of Isabel's family weighed their dishes, and this is what they found. So what we need to do is determine if the cost is proportional to the weight. So here are the different bowls of frozen yogurt. So the question is, does everyone pay the same cost per ounce, and how do you know? So how could we go about figuring it out? So this is similar to what we did in lesson 1. If it is $5 for every 12.5 ounces, or $4 for 10 ounces, or $2 for 5 ounces, or $3.20 for 8 ounces, how can we figure if they're the same? Well, we could figure out the unit rate like we did in the last lesson. So if it is $5 for 12.5 ounces, or $4 for 10 ounces, or $2 for 5 ounces, or $3.20 for 8 ounces, when we put all of these in the per 1 ounce, so this is dollars to ounces, if we did that arithmetic, 5 divided by 12.5 gets me 40 cents per 1 ounce. 4 divided by 10 is also, so $4 for 10 ounces, it's going to be 40 cents per 10. And again, to get those, per 1, all we are doing is dividing. We are dividing that 4 by 10. Or we're dividing 2 by 5. So once we do that division, we see that the cost is always 40 cents per 1 ounce. So the cost is 40 cents times the weight. So let's say there is another dish that is not here, that is not listed here. So another family member took a long time, and he ended up with a cup that that weighed 15 ounces. How could we determine that cost? What would we have to do? Well, now we know that each ounce is 40 cents. So we could take that 40 cents and multiply it by the number of ounces. So once we determine the cost, we can determine the cost by multiplying the 40 cents by 15 ounces. So his would have cost $6. So since this is true, since we are getting our cost by multiplying by the same number every time, we know that it is proportional. The cost is proportional to the weight. The cost is proportional to the weight. So what if you're like me and you don't order anything when we go to Orange Leaf? If you don't order anything, if the weight is 0, it's kind of silly because it seems obvious, but I want to make the point. Does this whole idea of multiplying by 40 cents still hold true? If I get 0 ounces, if I don't get anything at all, how much am I paying? Well, 0 times 40 cents is 0. So if I'm not getting anything, I'm not paying anything. So it still holds true. That's another way you can see if a relationship is proportional. You should have that 0, 0 relationship. So let's say the weight, that's our independent variable, and so that's going to be our x. So how do you find y for every x? Well, we know that every time we multiplied by 40 cents. And that, again, was our rate. 40 cents. We multiplied by 40 cents every time. So to get y, we had to multiply our x by 40 cents. So here is our rate. So the unit rate was 40 cents per 1 ounce. And here's our rate. And then here is actually the equation, the very easy equation. How did we get y? We multiplied the weight, or x, by 40 cents every time. All right, let's look at another example. This one is about a cooking cheat sheet. In the back of a recipe book, this is the diagram that is given to provide easy conversions. So my question to you is this a proportional relationship? Okay, so let's look at what it tells us. Here are the cups, and here are the ounces that corresponds with that number of cups. So if you have 0 cups, there's 0 ounces. If you have 4 ounces, it's a half a cup. If there are 8 ounces, it's 1 cup. So is this proportional? So one way to tell if it is proportional is to determine if there is that constant rate. Is it going up at a constant rate? Well, so what would we multiply 1/2 by to get to 4, or 1 to 8? What are we multiplying by each time? And how you figure this, if it's not easy for you to see, is remember you set up it's 4 ounces for every 1/2 cup, 8 for every 1 cup, 12 for every 1.5. And so we can divide this. 4 divided by 1/2 is 8. So it'd be 8 per 1. This is already 8 per 1. 12 divided by 1/2 is 8 per 1. And this one is easy to see. 16 divided by 2, and remember we're writing equivalent ratios, is 8 per 1. So these are equivalent ratios. All of these are the unit rates. So the unit rate is the same. We'd be multiplying by 8 every time. And right here we have that 0, 0 relationship. So yes, it is proportional. The ounces are proportional to the cups. So let's just change this a little bit. Now that we've determined it's proportional, let's say I cook for a very large family and this chart is not enough for me. I want to see how many ounces are in 4 cups or 8 cups. What would we do to figure out the number of ounces? Well, now we know that the rate is 8. So it is 8 ounces for every 1 cup. So we can multiply that by 8 to determine, so we can multiply the cups by 8 to determine the number of ounces. So 4 times 8 is 32, 8 times 8 is 64. So figuring that unit rate is a really easy way to continue the conversions. But to keep it simple, let's put variables on it. See if we can come up with the equation. So here's my x, my independent variable. Here's my y. What do we have to do to the x every time to get the y? So what are we doing to the cups to get the ounces? So if we're trying to figure out y, the number of ounces, what do we have to do? We have to multiply by 8 every time. So the very generic way of writing that in equation form is y equals 8 times the number of x. It doesn't mean that x is 8. It means that you're multiplying by x. X was 0, x was 1/2, x was 1, x was 1.5, x was 2. Then we changed it. We could put any number. Let's say I needed how many ounces were in 100 cups. Now I can put in 8 times 100. So I know that y, the number of ounces, would be 800. Once I write in equations, it always is important to check. So I'm going to change colors here and show you what I mean. Let's do green. So here's what I think my equation is. But it's really important to check to make sure if that works. So what I'm going to do is I'm going to choose different values from my original table to see if it works in my given equation. So remember, x is the cups, y is the ounces. So if I take these individual pairs, these pairs right here, do we end up with a true statement using my written equation? So I'm going to do 0, 0 first. So here's my ordered pair 0, 0. If I plug 0 in for x, remember that's the first one, do I get 0 for y? So does this make a true statement? 8 times 0 does equal 0, but it's really important that you test more than just one ordered pair. So let's do this one. So if I take for y equals 8x and I plug in 1 because that's my x, do I get 8 my y? I do. So the ordered pair 1, 8 worked. What about 16, 2? We'll test this one. So my ordered pair is 2, 16, because this is my x, this is my y. So if I use the equation that I wrote, does it make a true statement? Does 16 equal 8 times 2? It does. So I know that my equation is correct. All right, right now I'd like you to pause the video and try to do this on your own and see if you can answer these questions. This is where you check your understanding. See if you're getting it, see if you need to go back and rewatch something. So pause and see if you can do these problems, and then I'll come back and explain. All right, what did you come up with? Remember, if it's proportional, you're going to have this 0, 0 relationship here, but you need to be able to multiply the x, because remember, your independent is x, your dependent is y. So you need to multiply that independent variable, because calories depend on time, by the same number. And if you do the division, 11 divided by 1, 22 divided by 2, 33 divided by 3, you can see that every time you have to multiply by 11. You have to multiply by 11 every time. So yes, the time is always multiplied by the same number 11 to find the calories burned. So it is proportional. So now let's take the information that we just learned and apply it to a new situation. Say Jose jumped for 6.5 minutes, so 6.5 minutes. How many calories would he be expected to burn? Well, we know that you have to take, to get your y, the calories, you have to take that x and multiply it by 11. So 6.5 times 11. And feel free to use a calculator. It's completely fine with me. It turns out to be 71.5 calories. So we took our rate, okay, the rate that you are burning calories per 1 minute. The rate, again, is how many calories per 1 minute, and we multiplied it by the time to get our total calories burned. All right, one last example. This is about a summer job. Alex spent the summer helping out his family's business. He was hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system at the end of the summer? So we have to first figure out, what is that rate? He didn't tell us. It's not in the problem. So how on earth can we find how much he is making per week? So how much do you think that Alex made after 2 weeks? Well, it stands to reason, given what we know, that possibly he was just doubling. So if he made $28 in the first week, how much would he make in the second week? Well, we can double that to 56. Where do you think these two ordered pairs came from, 128 and 4112? Well, the two pairs of data probably came from, or they did for sure come from, the data point. This is how much he had after 4 weeks. This is how much he had after 1 week. So we can hopefully fill out the rest of the table from that. So I'm going to check to see if they're, so far what we know is proportional. So if he made $112 in 4 weeks, how much did he make in 1 week? Well, we have that number right here, but I want to make sure that the rate is the same. So 4 goes into 112 28 times. So that is our rate. 2 times 28 is 56. 4 times 28 is 112. So that is our rate. So how can we determine if he's going to have enough money at the end of the summer? Well, filling out the table might help us. After 0 weeks, that one's easy. It's 0. And you're just really taking this number of weeks and multiplying it by 28 every time. So after 3 weeks, he had $84. After 5 weeks, he had a $140. And again, how we're figuring this out is it seems like he is making $28 per 1 hour. So we're just taking the number of, per 1 week. Per 1 week. Taking that number of weeks and multiplying it by 28. So 6 times 28 is 168. 7 times 28 is 196. And 8 times 28 is 224. And that's in dollars. So what this tells us is that if there were 8 weeks in his summer, if there are 8 weeks in his summer, then he has just enough, if you're not including tax, because he made $224 and the gaming system was already only $220. So yes, if he continues at this same rate, which was 28 per 1 week, so $28, he would have enough after 8 weeks. So let's go back to the point of this lesson. Is this proportional or not? Is this relationship proportional? Well, remember the central way that you can figure that out is if the measures of the second quantity is divided by, so if we set it up as a ratio, 56 to 2, and then divide them out, 112 divided by 4, if we set it up as that ratio and divide, do you come up with the same rate? And we did. Every time it was $28 per 1 week. So we can recognize proportional relationships when looking at a table by if each of the measures of the second quantity is divided by its corresponding measure in the first quantity. So here's the second quantity, here's the first quantity, second quantity, first quantity. So if we do that division, and it produces the same number, which by the way, that same number is called a constant. So this is the constant. We are constantly multiplying by the same number, called a constant. Then the two quantities are proportional. All right, so the lesson summary, this is kind of like your cheat sheet. So what we hopefully learned is if you measures in one quantity are proportional to the measures of a second quantity is if there is a positive number k. K stands for constant, even though constant starts with C. This is constant. So if there is some number k that for every x, the corresponding y is given by multiplying that constant by x, it reproduces this equation, then it's proportional. For example, because that's a little wordy, we took, in our first example, we were trying to figure out the weight and the cost of frozen yogurt. Every time we figured the total cost by multiplying the ounces by 40. So this would be our K. In the second example, we were trying to find out the ounces given the cups. So how many ounces were they given cups? So the cups was your X, and you multiplied by 8 every time. So this was your K, or your constant. So your independent variable, your dependent variable, and the constant. So it fits this pattern every time, where K is that constant, or the rate. It's the rate. So you're multiplying by the rate every time. In the third example, so we have this general framework. In the third example, when you're trying to figure out the calories burned based on time, you always multiplied the time, the number of minutes, by 11 to figure out the calories burned. So this is our constant, this was the calories, and this was the minutes. And it fits this framework, y equals kx. So now that we have summarized, hopefully you have an understanding of what the equation would look like and how you figure out if it's proportional from a table by doing that division and seeing if you can multiply the x by the y every time to get by the same constant. Now please continue to work and complete your problem set.